Now we will move on to the problems on functional dependency. It will be good if you can try the problems and then check for the solution. An instance of a relation scheme R A, B, C has distinct values for attribute A. Can you conclude that A is a candidate key or not? A is not a candidate key because we are given a relation with three attributes A, B and C, but we have not been given any instance of that relation. We don't have any data so that we can conclude whether A is a primary key or a candidate key or not. So next one is, there is a relation is there given and some functional dependencies are also given. They are asking you to find out the key of R. So how you will find out the key? What is a primary key? The key should be able to determine all the attributes in the relation. So you apply closure on particular attribute and then check whether it is a key or not. We have four options given: CD, EC, AE and AC. If we take CD, C can determine, every attribute can determine itself. So C can determine C and D can determine, no, D cannot determine any attributes as the functional dependency is not there for D. So C can determine F, that's there. Nothing can it determine. It can determine only C and D. Now if you take EC, EC can determine D and obviously EC can determine E and C. So C can determine F, E can determine A can determine B. So everything is there, A, B, C, D, E, F, everything is there. So that's the answer. Next question, we are given a relationship instance. That's what I told about the first question. We don't have any instance, that's why we cannot say whether A is a candidate key or not. Now we are given an instance, we are asked to say whether which function dependency will be satisfied by this instance. You can check for taking the left hand side value and right hand side value. If it is unique values are there, then we can say that it is the functional dependency will hold. For example, the first one, xy determines z and z determines y. For xy 1 4 it is 2, 1 6 it is 3, it's okay, 3 2 it is 2, and z determines y. 2, for 2 we have 4 and 2, so the functional dependency will not hold. Now the second option, yz determines x. 4 2 determines x, 5 3 1 6 3 1, and y determines z will also hold because for every unique y value we have a unique z. So that will be the answer. Now here is another problem. They have given different attributes and the functional dependencies which are holding on that attributes. We are asked to find the candidate key. So as said for the earlier question, you have to determine using the closure. You have to take the closure from the given option and you can try out whether it is able to derive all the other attributes, then it will be a candidate key. Here Vxy will be a candidate key as Vy can determine W and X is already there, Wx can determine Z. So everything is there, V, W, X, Y, Z. The next question is, you are given an instance of a relation. They are asking to the student name and student age to be a key. The what value of x it should not be equal to. So you are given four options, which value it should be, so that which value it should not be, so that the student name and student age is a key, is a primary key. Clearly you can see that it is 19, as Shankar 19 already exists. We cannot have another value, same value Shankar 19, so it should not be 19, others are fine. Here is also another question. which is asking you to calculate the key for the given relation R. You can come up with the closure and try the solution. The solution is there in the slide. The next question is, which of the following is not a super key in a relation schema with attributes V, W, X, Y and Z? And they are saying the primary key is Vy. So what is a super key? Go back to the definition and check it. In order to be a super key, in order to be a key, it is a minimal super key. So Vy should be there for every super key so that it can be a super key. Now in this option VW XZ, there is no Y attribute, so it cannot be a super key. That is the answer. Now we'll move on to the problems for normalization. So we are given a database relation and what are the attributes, and they are saying that it is atomic, and we are given two functional dependencies, A determines C and B determines D. They are asking what is the normal form for this relation. So first of all, for determining normal form, we have to find out the keys. Here what will be the key? So A can determine C, B can determine D. So A and B together will act as a key. So now we will go on to the normal form definitions. They are saying that the attributes are atomic value, so obviously it will be in first normal form. Now we will check the condition for second normal form. The second normal form says that every non-prime attribute should be fully functionally dependent on first prime attribute. So here C and D are non-prime attributes, so they should be completely dependent on prime attributes, but here they are partially dependent on A and B. So it is in the relationship, it is in first normal form. Now the second question, we have been given some functional dependencies. You assume that the values are atomic and they are giving a relation, roll number, name and date of birth and age, and asking which is in which normal form. So first of all you have to determine the key and then come out with the you have to try out which normal form it is. As it is atomic, it should be first normal form. Then you have to try the condition for second normal form and then third normal form. The answer will be first normal form. You can try it out yourself. The third question is, we are given a relation with functional dependencies. They are asking you to find out the highest normal form possible for the relation. So here also we have to determine the keys. So you can see that name, course number and roll number, course number, they both can determine every other attributes. You can see that name, course number can determine grade and name can determine roll number. So the name, course number can determine every other attributes. Also roll number, course number can also determine every other attributes. So they both are candidate keys. You can take anyone as the primary key, they both are candidate key. So what you have to do, you have to check the conditions for different normal forms. First normal form, by default it will be there. The second normal form, there should not be any partial dependency. So non-prime attribute, here it is grade. So non-prime attribute, it is fully functionally dependent. And so second normal form holds. So we will go to the third normal form. Third normal form says that for X determines A functional dependency, X should be a super key or Y should be a prime attribute. Here roll number is a prime attribute for the third functional dependency, and name is also a prime attribute for the fourth functional dependency. So the third normal form also holds. So this, the highest normal form will be third. Now the fourth question, they are given 5 attributes for a function, for a table, and the dependencies are also given. F1 gives F3, F2 gives F4, F1, F2 gives F5. So we have to find out what is the candidate key. Here F3, F4, F5 can all determined by some functional dependency. So F1 and F2 will be the candidate key. So F1 and F2 can determine F3, F4, F5 and itself F1 and F2. But the non-prime attributes F3 and F4 and F5 should be fully functionally dependent on F1 and F2. But here they are depending upon F1 and F2 separately. So it is not in second normal form. We can conclude that this is in first normal form. Thank you.